In today's lesson, we will be going through a distance time graph and a velocity time graph side by side, so you can see the differences and the things that are asked about these graphs. So let's go. Part A deals with a distance time graph for a car undergoing a journey. So let's take a look. The graph shows how far the car travelled and how long it took. And we are given the following table, and it says between which points was the car travelling fastest? Tick your answer. So thinking back to what I taught in the previous lesson, on a distance time graph, whenever you see straight lines, horizontal straight lines, that indicates the object has stopped. Whereas whenever you see a constant gradient on a line moving upwards or downwards, that indicates constant speed. So our choice is either A to B or B or E to F. So the answer is going to be E to F. And the reason why is because that part of the journey has a steeper gradient compared to A and B, which means the car has covered a greater distance during that time. So E to F. Right, the next bit is on a velocity time graph for the car. Now this one's a little bit more involved, and you can see that from the number of marks involved, 4 marks. So figure 6 shows the graph of the car's movement. Show that the distance travelled when the car is moving at constant speed is greater than the distance travelled when the car is slowing down. First of all, we need to locate where the car is moving at constant speed. So again, what I discussed in the previous video is that when you see a horizontal straight line on a velocity time graph, that indicates is when the car is moving at a constant speed. When the line is either increasing at a constant rate, like it is there, or even curving like that, that means acceleration, or in this case, if it's going downwards, deceleration, which is either constant, also known as linear, or non-linear when it's curving. The car is slowing down between points C and D. What I need to show is the distance covered when the car is slowing down is less than the amount in this red box. You can see that the scale is on this side is 28, 29, 30, 31. It's a difficult scale, so it's about, if you look at C, 28, 29, it's about 30. And then if we go down, you can see that it begins slowing down at about, if I just do a dotted line here, 41 seconds. So we've got this triangle there. Right, before I get into how to prove this, I need to make a statement. So I'm going to write this in blue. Right, so you'll need to take this down for your notes. The area underneath a velocity time graph is equal to the distance covered by that particular object. So what I've got to prove is that the distance under AB is greater than the distance CD. So the area of this rectangle must be greater than the area of the green triangle. So let's go ahead and work it out. Then between C and D, so the area of a triangle is half times the base times the height, and therefore we have shown that this number is less than this number. So therefore the distance covered down is less than at constant speed.